Hi, and welcome back to the Core Learning channel. Today I'm going to be going through the November 2022 Maths GCSE Higher Tier Paper 1, so this is non-calculator. I'll be going through each question and showing how I'd go about getting the answer. So if you haven't already, please hit that like button, providing you found this useful, and subscribe to our channel. This really helps us grow and reach more people, so your support really does help. And with that, let's jump into our questions. So for question 1, we have minus 4 times minus 7 over 9. So if we times the minus 4 by the minus 7, the minuses cancel out and we get 28, and then we're left with the 9 in the denominator. So our answer here is 28 over 9. And for question 2, we have the square root of 6 to the power of 4. So what this is equivalent to is root 6 times root 6 times root 6 times root 6. Now, root 6 times root 6 is just 6. So what this boils down to is 6 times 6. So our answer here is 36. So for question 3, we are told that 0.203 is equal to a fifth plus x. And what we want to do is find the value of x. So let's rearrange this and move that fifth across to the left-hand side. So we have 0.203 minus 1 over 5 equals x. Now let's rewrite this fraction 1 over 5 as a decimal. So 1 over 5 is equal to 0.2. So if we plug this into what we've got now, we have x is equal to 0.203 minus 0.2, which equals 0.003, and as a fraction 0.003 is 3 over 1,000. So moving on to question 4, and what we have here are 4 sets of equivalencies. Now an equivalency is represented by this triple equal sign. What this means is it's identical to but not exactly the same. So if I were to give you an example, a half is identical to 2 over 4, but it isn't exactly the same. So here we can see that the correct answer should be 3x is identical to x plus 2x. So moving on to question 5, and we're asked to split 62 in the ratio 3 to 7. So what we're going to do here is we're going to divide 62 by 3 plus 7. Now what this is going to do, this is going to tell us what 1 unit is equal to. So the ratio is 3 to 7, so there are 10 parts or 10 units within this ratio. We want to know what just one of those units are. So when we do this, we have 62 over 10, which is 6.2. And now what we can do that we have this 1 unit is we can multiply by 3 to find what 3 units is equal to. So in this case, it's going to be 18.6. And we can do the same to find 7 units, so we multiply by 7. And this gives us 43.4. And this is how we're going to split out 62 in the ratio 3 to 7. So this is going to be equal to 18.6 to 43.4. And just a quick litmus test here. If you add these together, we should get 62, which we do. So let's move on to question 6. And here we have a frequency table, which is looking at how long samples of men and women would spend on social media. And we can see here we've got 5 intervals. Now we have several different statements and we have to assess whether it's definitely true, might be true, or cannot be true. So the first one says that 3 of the women spent more than 11 hours on social media. So in this case, we're looking at the last two rows. These last two rows represent women who spent above 11 hours on social media. So you can see we have 2 who spent between greater than 11 and equal to or less than 14, and 1 which was greater than 14 and equal to or less than 17. So 2 plus 1 is 3. So this statement is definitely true. So the second statement here is that the range for the men is 15 hours. So the range is the difference between the least amount of hours a man spent and the most amount of hours a man spent. So what is the lowest number of hours one of the men could have theoretically spent? Well, there were 10 men in this greater than 2, equal to or less than 5 interval. So theoretically, one of these 10 men could have spent just over 2 hours. And there were no men for the highest interval bracket here. So the next highest interval bracket where there were men within the interval was greater than 11 and equal to or less than 14. So the highest value they could have theoretically had would have been 14. So this would give us a maximum range of just below 12 hours. So this cannot be true. So for this last statement, we're told that the women have a higher median than the men. So the median is just going to be where the middle of the sample size lies. So if we have 40 people in each sample, i.e. the men and the women, then the median is going to be the 20th person. So what we want to do is take the cumulative frequency for the women and for the men. Cumulative frequency means we just take a running total so far. So for the women, I'll quickly just write down the values. So we have 12, 11, 14, 2 and 1. So we start with 12. So our first total is just 12 because we obviously started from 0. We then add the next value, which is 11, which brings us to 23. We then add 14, which takes us to 37. And then we add the 2, and we get 39, and then we add the 1, and we get 40. So one way to make sure you've done the cumulative frequency correctly is that the value in the final row should be the total sample size. And again, going to the men. For the men, we have 10, 17, and in fact, if we start with 10 and then we add the 17, we get 27. So I'm not going to go any further than that. So basically, what we were looking for is in which interval was the 20th person situated. So we can see that for the women, we get to 23. So we go from 12 to 23. So we know that in that greater than 5 and equal to or less than 8 interval was where that 20th person occurred. Likewise for the men, we go from 10 to 27. So we know that likewise the 20th person was in the range greater than 5 and equal to or less than 8. So we know that the median value occurred in that range. We don't know, though, the exact value for that median person, i.e. that 20th person might have spent 6 hours on their phone for the women, and for the men they spent 7 hours. But we don't have that information. We just know that they lie in the same interval. Therefore, this might be true. So moving on to question 7, we are shown 2 vectors A and B, and for part A we want to know what B is as a column vector. So we can see A written as a column vector here. So the column vector just means the numbers are on top of each other. So the first number is the x coordinate and the second number below is the y coordinate. Now what this means is if we go to the starting point of a line, so for instance A, and we take the starting point, which is the point at which the arrow is moving away from, it's saying to get to the end point, how many do we have to go in the x direction and how many do we have to go in the y direction? So for A, from that starting point, we go 3 plus 3 in the x direction and plus 2 in the y direction. So for B, you can see that we go plus 4 in the x direction and then minus 1 in the y direction. So the answer here is 4 minus 1. So for part B of this question, we're asked to work out what the column vector for 4A is going to be. So a reminder, if we multiply a value, in this case I'm going to call it A, by a column vector with values x and y, the corresponding column vector is going to be A times each element in that column vector. So in this case it would be A times x, A times y. So if we want to take 4A, we'll do 4 times the column vector 3, 2. So we multiply each value in the column vector by 4, and this is 4 times 3 and 4 times 2. So we end up with the column vector of 12, 8. So for part C, we're told that A plus C is equal to the column vector 3, 0. Now let's just remind ourselves, if we have a column vector D, which has the values x1 and y1, and another column vector E, which has the values x2 and y2, then D plus E is going to be a column vector of values x1 plus x2 and y1 plus y2. So we add the like elements together. So if we know that A plus C is equal to the column vector 3, 0, then by rearranging to find the value of C, C is going to be equal to the column vector 3, 0 minus A. So C is going to be equal to 3, 0 minus 3, 2. So C is going to be equal to the column vector 3, 0 minus the column vector 3, 2. So if we subtract the x element of each column vector, we have 3 minus 3. And if we subtract the y elements, we have 0 minus 2. So 3 minus 3 is 0, 0 minus 2 is minus 2, so C is equal to the column vector 0 minus 2. So moving on to question 8, and we have 7 tenths minus 4 fifteenths divided by 2 over 3. So let's break this down into two parts. Part 1, we're going to work out what 7 over 10 minus 4 over 15 is. And then we're going to, after we've simplified that, we're going to bring that back in and divide it by 2 over 3. So that's the second part. So for part 1, 7 over 10 minus 4 over 15. We need to find a common denominator here. So I'm going to try and get a denominator of 30, as this is divisible by both 10 and 15. So if we want to get 7 over 10 in the form something over 30, we have to multiply top and bottom by 3, which gives us 21 over 30. And for the 4 over 15, we have to multiply top and bottom by 2, which gives us 8 over 30. So we're left with 21 over 30 minus 8 over 30. We can now combine the numerators as we have the same denominator. So this is 21 minus 8 over 30, which is 13 over 30. So now, going back to what we originally had, we can simplify this as 13 over 30 divided by 2 over 3. Now we can use a nice little trick here, which is that if we have a fraction a over b and we're dividing it by the fraction c over d, this is equivalent to a over b times d over c. So we can change it to a multiplication by flipping the later fraction. So this is actually equal to 13 over 30 times 3 over 2. So when we do this, we get 39 over 60. And this, of course, can be simplified. If we divide top and bottom by 3, we get 13 over 20. So moving on to question 9, and we're asked to find all integer values of x which satisfy the condition that 4x is equal to or greater than 12 and less than 25. So what I'm going to do here is I'm going to plot out some values of x and the corresponding values of 4x. So I've got x, and let's just go up to 7 for now, and we can add more if we need to. So when x equals 1, 4x is 4. When x equals 2, 8. So what we want to look for is in this 4x row, which values satisfy the above condition. So which values are equal to or greater than 12 and less than 25. And you can see here those values are 12, 16, 20 and 24. So this is when x is equal to 3, 4, 5 and 6. So moving on to question 10, and here you can see that we're asked to write out a Venn diagram for people buying coats and dresses in a shop. And we're given a few bits of information, and that's that 3/4 of the people buy neither a coat or a dress. We have that 19 people buy a coat, and we have that 14 people buy a dress. And we're told that in total 120 people visit the shop. So we want to fill in the number of people who just buy a coat, the number of people who buy both, the number of people who buy just a dress, and the number of people who don't buy anything. So the first thing that we can work out here is going to be the number of people who buy nothing. So we know that 120 people have visited the shop. 120 people have visited the shop, and we're told that 3/4 of those buy neither a coat nor a dress. So in this case, to find the value in the bottom right hand corner, it's just going to be 3/4 times 120, and this is 90. Now, given that 90 people didn't buy anything, this means 30 people did buy something. So what we can say is that there are going to be 30 people who bought either a coat or a dress or both in total. So what we can do now is we can say the number of people who bought a coat and a dress I'm going to call X, because we don't know this information. We also don't know who bought just a coat or just a dress. All we know is that 19 people bought a coat, but they may have also bought a dress. Likewise, 14 people bought a dress, but they may have also bought a coat. So let's call this value intersecting C and D as X. And what this means is that for people who just bought coats, that number is going to be 19 minus this value X, because this is for people who just bought a coat. So it's 19 minus this value who bought both. Likewise for dresses, it's going to be 14, which is the total number of people who bought a dress, whether that was just a dress or a dress and a coat, minus the people who bought both. So what we have now, we have the number of people who bought a coat as 19 minus X, the number of people who bought both as X, and the number of people who just bought a dress as 14 minus X. And when we add all of these together, this should give us 30. And what we want to do is solve for X. So we have 19 minus X plus 14 minus X plus X equals 30. So we have, in this case, the X's cancel out. So we have a minus X and a plus X. These cancel. And we are left with 19 plus 14 minus 30 equals X. So this gives us that X is equal to 3. And now what we can do is just fill in our value of X. So we have that 3 people bought a coat and a dress. We have 19 minus X, which is 19 minus 3. So this is 16 people who bought just a coat. And we have 14 minus 3, which is 11 people who bought just a dress. So moving on to question 11, we have the ratio 3 to the 6 times 3 to the 5 to 3 to the power of 7. And we want to rewrite this as the ratio n to 1. So what we're going to do is we're going to concentrate first on this 3 to the 6 times 3 to the power of 5. And the rule here we're going to use is that a number n to the power of x times n to the power of y is equivalent to n to the power of x plus y. So using this rule, 3 to the power of 6 times 3 to the power of 5 is going to be 3 to the power of 6 plus 5, which is 3 to the 11. So we have the ratio 3 to the 11 to 3 to the 7. What I'm going to do here is I'm going to divide both sides by 3 to the 7. So on the left hand side we have 3 to the 11 over 3 to the 7. And the rule we can use here is that if we have n to the power of x divided by n to the power of y, this is equivalent to n to the power of x minus y. So this would be equivalent to 3 to the power of 11 minus 7. And then on the right hand side, we have 3 to the 7 over 3 to the 7. Well, this is just 1. So we have 3 to the power of 11 minus 7 to 1, which is 3 to the power of 4 to 1. 3 to the power of 4 is just 3 times 3 times 3 times 3. So the answer here is 81 to the power of, pardon me, the answer here is 81 to 1. So for question 12, we're told that A is 10% more than B, and we want to know what the ratio A to B is. So what I want to do is write this in a specific way. So we have A is 10% more than B, and a way we can write this is that A is equal to B plus 10% of B. Now 10% of B as a decimal is 0.1B. So A is equal to B plus 0.1B. We add these together and we get that A is equal to 1.1B. So now what we can do, if we times both sides by 10, we have that 10A is equal to 11B. So now, if we rearrange this, we get that A over B is equal to 11 over 10. And what this means is that the ratio A to B is the ratio 11 to 10. Moving on to question 13, we're asked to work out 0.47 reoccurring plus 0.312. So 0.47 reoccurring is just 0.4 with an infinite number of 7s after. So if we add 0.312, we're going to get 0.789, and then we're still going to have that infinite number of 7s after that point. So when we add this together, we have 0.789, 7 reoccurring. So for question 14, we're told that Craig wants to draw a graph for values of x from -3 to 3, and where the x coordinate and y coordinate are always in the ratio 2 to 1. So this last point is referring to the gradient. So we know the gradient is the change in y over the change in x. So in this case, he'd want a constant gradient of a half, because for every 1 unit change in y, there'd be a 2 unit change in x, so 1 over 2. So we're going to make 2 criticisms of the graph he has drawn here. Number 1, well, we can see here that the graph only goes from x equals 0 to x equals 3. So it hasn't included the full range of -3 to 3. And if we look here, for every unit change in x, we have a change in y of 2. So this would be a gradient of 2, not a gradient of a half. So moving on to question 15, and we're asked to prove that 3x plus 4 times 2x minus 5 minus 11x times x minus 2 plus 5 times x squared minus 3x minus 1 simplifies to an integer. So let's break this down into 3 parts. So part 1 is going to be this 3x plus 4 times 2x minus 5. So this is the first brackets, we expand. Then we have this minus 11x times x minus 2. So this is the second part. And the third part is this 5 times x squared minus 3x minus 1. So for part 1, 3x plus 4 times 2x minus 5. Let's expand these brackets. brackets. So we have this 3x times 2x, which is 6x squared. And then we have 3x times minus 5, which is minus 15x. Then we have the plus 4 times 2x, which is plus 8x. And we have the plus 4 times minus 5, which is minus 20. So we can tidy this up slightly in the middle. So we have 6x squared, and then the minus 15x plus 8x is just minus 7x, and we still have the minus 20 on the end. Moving on to part 2, we have minus 11x times x minus 2. So minus 11x times x is minus 11x squared, and minus 11x times minus 2 is plus 22x, so just be careful with those negative signs. And lastly, we have 5 times x squared minus 3x minus 1, and this is 5x squared minus 15x minus 5. So bringing all these parts together, so if we add parts 1, 2 and 3, we have 6x squared minus 7x minus 20, minus 11x squared plus 22x, plus 5x squared minus 15x minus 5. So let's just group these together by the different terms. So first of all, we have our x squared terms. So here we have 6x squared minus 11x squared plus 5x squared. Then we have our x terms, which are minus 7x plus 22x, minus 15x. And then lastly, we have our number terms, which are minus 20 minus 5. So if we go through each of those parts, for the x squared terms, we have 6x squared minus 11x squared plus 5x squared, that's 0. We have minus 7x plus 22x minus 15x, that is also 0. And lastly, we have this minus 25 on the end. So we can see, in fact, that this does simplify to minus 25, which is an integer. Moving on to question 16, and we're told that we have a line on a graph which is represented by the equation y is equal to x squared plus px plus r, where p and r are constants, and we're told that some coordinates on this graph are 0, 4, 1, 3, and 8w. And we want to find out what this coordinate w is. So the first thing that I'm going to do here, and I'm just going to label these coordinates x and y. So what I'm going to do here is I'm going to use these coordinates to find out the value of the last set of coordinates. So I'm going to use this first coordinate here. So this first coordinate, we have that x is 0. And this is quite handy because it eliminates this p constant for us. So when x is 0, y is equal to 4. So the equation at the top becomes 4 is equal to 0 squared plus p times 0 plus r. So we now know that r is equal to 4. So let's rewrite out what we now know, which is that the equation is y is equal to x squared plus px plus 4, where we still need to work out what p is. So what we're going to do now is we're going to use the next coordinate, which we know, to work out the value of p, because we only have one unknown in this equation. So let's use the second coordinate that we're given, which is the coordinate x equals 1, y equals 3. So plugging these values in, we have that 3 is equal to 1 squared plus 1 times p plus 4. So simplifying this, we get that 3 is equal to 1 plus p plus 4. So rearranging to find the value of p, we have that p is equal to 3 minus 1 minus 4, which is minus 2. So now we can write out the equation of our quadratic, which is y is equal to x squared minus 2x plus 4. We can now use this to work out our value of w. So w here is our y coordinate and our x coordinate is 8. So w is equal to 8 squared minus 2 times 8 plus 4. So this is 64 minus 16 plus 4, which is 52. So for question 17, we're told that the height of 60 athletes is recorded and put into this frequency table. And what we want to work out is the cumulative frequency. So cumulative frequency is just a running total up to a certain point. So we can see for h, or height, is equal to or less than 170, that's just the total number of people below that point. So we had 4 in 150 or greater than 150 and equal to or less than 160, and 12 greater than 160 or equal to or less than 170. So the total up to that point is 4 plus 12, which is 16. So continuing on those lines, for the height is equal to or less than 180, is going to be this 16 that we've just recorded plus the 35 in that 170 to 180 interval. So this is going to give us 51, and then to this 51 we add the 7 between 180 and 190, so this gives us 58, and then we have 2 from 190 to 200, so this gives us 60. And we know we've done this right because the last value should be the total sample size. So for part B, we're asked to find the interval that contains the lower quartile. So the lower quartile is just going to be where the person who represents a quarter of the total sample size lies. So the total sample size here is 60. So a quarter of 60 is 15. So we want to find in which interval does the 15th person lie. And using the frequency diagram, we can see here that the 15th person is going to be in this interval of greater than 160 and equal to or less than 170. So moving on to part C, and we're told to plot the cumulative frequency table, diagram even. So here, we've already worked out the cumulative frequency table, so we just need to plot these points. So for height less than or equal to 150, we have 0. And then for 160, we have 4. And then for equal to or less than 170, we have 16. And I'll just go through and plot the rest of the points. And now the key here when we do this is we don't want to draw a straight line, so we do a nice curved line to join the points up. So this is our cumulative frequency diagram. And then for part D, we are asked to estimate the number of athletes whose height is more than 176. So what we're going to do here is, if we go to 176 centimeters, and we just want to find whereabouts that hits the line. So we can see here that it's roughly about this point here. So roughly hits about 40 people. So our answer is that the number of people above this point is this many people. So it's going to be roughly in the region of about 20 people with a height greater than 176 so for question 18, centimeters. We're told that a road is split up into 3 sections, which are D, E, and F, and they have the following ratios between each other. D to E has a ratio of 3 to 5, and E to F has a ratio of 7 to 4. And we want to know what the fraction of D is as a fraction of the total length of the road. So what I'm going to do here is we've got D to E and E to F. I'm going to reverse this and make this F to E. So we now have F to E is the ratio 4 to 7. And just to make this a little bit easier, I'm going to write these as fractions. So we've got D over E is 3 over 5, and F over E is 4 over 7. And the way we want to think about this is we want a common denominator here. So currently we have a denominator of 5 and a denominator of 7. So let's try and make a denominator of 35. So if we have a denominator of 35, then d over e could be written as 21 over 35, and f of e could be written as 20 over 35. So now that we've done this, we can write the ratio d to e to f to be 21 to 35 to 20. So if we add all these parts up, so 21 plus 20 plus 35, this gives us the total length of the road, and this is 76. And therefore d as a fraction of this total is going to be 21 out of 76. So for question 19, part A, we're told to work out 5 over 4 to the power of minus 2. And the thing I'm going to use here is that if we have x to some power minus n, this is equivalent to 1 over x to the power of n. So 5 over 4 to the power of minus 2 is the same as 1 over 5 over 4 to the power of 2. 5 over 4 to the power of 2 is 5 over 4 squared. 5 over 4 squared is 25 over 16. So this is equivalent to 1 over 25 over 16. So 1 over a fraction just means we can flip the fraction. So this becomes 16 over 25. So for part B, we're asked to work out what 9 over 100 to the power of 3 over 2 is. So this time, I'm going to use the rule that when we have x to the power of a to the power of b, this is equivalent to x to the power of a times b. And what I'm going to do here is I'm going to use this to rewrite the initial expression we have, and I'm going to rewrite this as 9 over 100 to the power of a half, all raised to the power of 3, because we have that half raised to the power of a 3, which is the same as a half times 3, which is 9 over 100 to the power of 3 over 2. So if I look at this 9 over 100 to the power of a half and simplify this first, well, what this means is I just apply a power of a half to each part of that fraction. So this is 9 to the power of a half over 100 to the power of a half. And something to the power of a half is just the square root. So we have the square root of 9 over the square root of 100. This is, of course, equal to 3 over 10. So plugging this back in to the original expression, we now have 3 over 10 cubed. And again, we can apply this cube to the numerator and the denominator. So this becomes 3 cubed over 10 cubed, which is 81 over 1,000. So moving on to question 20. We're told that x squared plus bx plus c equals 0 has only one solution, which is that x equals minus 15. And we're told to work out the values of b and c. Now, we could go about this by trying to factorise, but for me, I think the easiest way to do this is going to be to use the quadratic formula. Now, as a reminder, the quadratic formula says that our solutions of x to a quadratic equation are given by minus b plus or minus the square root of b squared minus 4 times a times c over 2a, where a, b and c are going to be the coefficients. So these are the values that come before the x squared, the x and the number term. So one thing we can deduce using the quadratic formula is that generally we're going to have two solutions because there's this minus b plus or minus. So you can imagine if our value of b was 10, for example, and this root b squared minus 4ac was 5, then we'd have minus 10 plus 5, which is minus 5, and then we'd have minus 10 minus 5, which is minus 15. So as long as this b squared minus 4ac has a value that's not 0, then we're going to get two solutions. But we're told here that we only have one solution. So in this particular case, we actually know that b squared minus 4 times a times c must equal 0 for there to be only one solution. Now what we need to start doing here is filling in some values in the quadratic formula. So we know that x equals minus 15 is a solution, so we can plug in minus 15 for x and set this equal to the rest of the quadratic formula. Now what do we know from here? Well, we don't know what c is, we don't know what b is, but a is just the coefficient before the x squared term, and in this case there is no value before the x squared term, so a is just 1. So we know what a is. So if we write this out, we have minus b plus or minus the square root of b squared minus 4 times 1 times c. But we know that we can just cross this out because we know that this is going to equal 0 because there's only one solution. So what we're left with is minus b plus or minus 0 over 2. So minus b over 2. In this case, this means that minus 15 equals... So we have minus b is equal to minus 15 times 2 if we carry the 2 across. So we have minus b equals minus 30, and therefore b equals 30. So now that we know that b is equal to 30, we can go back to this b squared minus 4ac, and given that we know a and now we know b, we can use this to work out the value of c, given that we know it must be equal to 0. So we have 30 squared minus 4 times 1 times c is 0. This means that 30 squared equals 4c, and therefore c equals 30 squared over 4. Well, 30 squared is 900, and 900 over 4 is 225. So the values here are that b equals 30 and c equals 225. So moving on to question 21, and we're asked to write the decimal 0.61 reoccurring as a fraction. Now what I'd really love to do here, and the method I'm going to use, is that I want to eliminate this recurring number. It's a real nuisance, I want to just get rid of it. Well, a way I can do this is I can say I'm going to call my 0.61 reoccurring r, and I'm going to take 100r. So 100r is going to be 61.1 reoccurring, and then I'm going to take 10r, which is 6.1 reoccurring, and I'm going to subtract those two terms. So I have 100r minus 10r. So this is 61.1 reoccurring minus 6.1 reoccurring. Now I've successfully gotten rid of my 1 reoccurring, and I'm just left with 55. Now this is 100r minus 10r, so this is 90r. So what we have is 90r is equal to 55, and therefore r is equal to 55 over 90, and we can simplify this down to 11 over 18. And let's remember, this r is our 0.61 reoccurring. So what this is saying is 0.61 reoccurring is equal to 11 over 18. So for question 22, we're told that the coordinate 4, 8 is a point on a circle with a centre at the origin, and there is a tangent at the coordinate 4, 8 which intersects the x-axis at this point P, and we want to work out what P is. So let's just clarify a few things. So this line that we're told is a tangent to the circle, what does this mean, a tangent to the circle? Well, what it means is the point at which this line touches the circle creates a right angle which goes from the point at which the line contacts the circle all the way to the centre of the circle, which in this case is at the origin. So I think what we want to do here is we want to try and work out what the equation of this straight line is. And the way we're going to do this is we're going to work out the gradient and try and do y equals mx plus c to find out what the equation of the line is. So one thing we have to note here is that if we say that this gradient, which goes from the origin of the circle to the point at which the line intersects, if we call this gradient m1, well, the relationship between m1 and then what I'm going to call m2, which is the gradient of the straight line. So the relationship for those two lines, given that they're at a right angle to each other, or perpendicular if you will, is that m2 is going to be equal to minus 1 over m1. This is just a rule that you need to know about the gradients of perpendicular lines. So given that we know the origin coordinates, and given that we know the point at which the line intersects the circle, we can work out what the gradient of m1 is. So the gradient of m1 is going to be the change in x, which in this case is going from 0 to 4. So the change in x is 4, and the change in y is going from 0 to 8. So the change in y is going to be 8. So the gradient of a line is given by the change in y over the change in x. So in this case, it's going to be 8 over 4, which equals 2. Given that we've just worked out m1, we know that m2 is going to be equal to minus 1 over 2, which is minus a half. So we can now say the straight line which intersects this circle is going to have a straight line equation which is y equals minus a half x plus c. So now that we know this, we can use this to work out what the value of c is. So given that we know a point on this straight line is the coordinate 4, 8, we can plug these values of x and y into our straight line equation to isolate c. So we have a y value of 8 and an x value of 4. We plug these in and we have 8 equals minus a half times 4 plus c. So if we rearrange that slightly, we're going to have 8 equals minus 2 plus c, and therefore 8 plus 2 equals c, so c equals 10. So now the equation of our straight line is going to be that y equals minus a half x plus 10. Now that we know this, and we know that for something to cross the x-axis, this means that it has a y coordinate of 0, we can plug in the value of 0 for y, and we can use this to determine the value of x. So in this case, when we plug in y equals 0, we have 0 equals minus a half times x plus 10. Well, if we rearrange this slightly and we move the minus a half x over to the other side, we now have half x equals 10, and therefore x equals 10 times 2, which is 20. So moving on to question 23, and we're told that 4 times sine of 30 degrees times the tan of 30 degrees times the cos of 30 degrees is equal to sine y. And we're asked to work out a value of y. So what I'm going to make use of here is one of the trig identities, which is that the tan of some number x is equal to the sine of x over the cos of x. So in our particular case, we'd have that tan of 30 degrees is equal to sine of 30 degrees over cos of 30 degrees. So what I'm going to do is substitute this sine of 30 degrees over cos of 30 degrees for tan of 30 degrees, and what I get then is 4 times the sine of 30 degrees times the sine of 30 degrees over cos of 30 degrees times cos of 30 degrees. And this is equal to the sine of y. So you notice here I can cross out the two cos of 30 degrees, as we have one in the numerator and one in the denominator. And we're left with 4 sine 30 degrees, which is 4 times sine squared 30 degrees. And this is equal to the sine of y. So now what I'm going to make use of is there are certain trigonometric values that we should know, and one of them is definitely the sine of 30 degrees. So you should know that the sine of 30 degrees is a half. So what we're going to do is go ahead and plug in half where we have sine of 30 degrees. So this leaves us with 4 times a half squared, as it's sine squared, which is equal to the sine of y. So 4 times a half squared, well, that's 4 times a quarter, which is 1. So we're left with the sine of y is equal to 1. So what I want to do now, I'm going to go ahead and draw out the sine of y graph. And you notice here I've put the y on what would commonly be the x-axis. So obviously this is a sine of y graph. So our y values run along the horizontal axis. And then I've called my other axis x. So let's just put in a few values of y. So we've got our 90 degrees, 180 degrees, and we're going to go up to 450 degrees. And I also have my two x values, which are -1 and 1, or I should say my two x limits. And I'm just going to start plotting out this graph. So when y is equal to 0, x is going to be equal to 0. When y is 90 degrees, x is 1. When y is 180 degrees, x is 0 again. And we're just going to draw out this sine curve all the way up to 450 degrees. Now this is saying we want to know what values of y, when applied to this graph, give us a value of 1. So this dotted line that I'm drawing, which goes across from 1, at what points does the graph of sine y touch this dotted line? Well, you can see it touches when y is 90 degrees. You can see it also touches when y is 450 degrees. So we're asked to work out one possible value of y. So you could just put 90 degrees. As a rule, the values for y here are going to be 90 degrees plus 360n, where n is an integer. And just to check this works, if n is 0, then y is 90 degrees. We know that's correct. If n is 1, then we have y is equal 450 degrees, which again, we know that's correct. And if we had n equals 2, we would have 810 degrees, which if you carried on drawing this, you would see is indeed a solution. So moving on to question 24, and we're given this shape which is defined by the points A, B and C. And we're going to apply some transformations here. So the first transformation we're asked to apply is a reflection in the line x equals 1. So let's draw a line which goes through the point x equals 1, and we want to reflect in this line. So to do this, let's just quickly jot down our coordinates. So for A has the coordinates -4, 3. B has the coordinates -4, 1. And C has the coordinates -1, 1. So we want to reflect about this line here. So we don't need to worry about the y coordinates because they're going to be the same in the reflection. But the x coordinates are the things that change. So if we were to look at this point A, if we're going to reflect, what we need to know is, what is the change from the line to this A coordinate? Well, it's a change of -5. So we need to create a change of +5 here. And this is going to be where our new A prime coordinate is. And we're going to follow this logic. Obviously, it's the same situation for B, as B has the same x coordinate as A. And given that the y coordinate stays the same, this is going to be our B prime. And then for C, we can see that we have this change here of -2. So we have a change here of +2. So our C coordinate is going to be here. So this is our C prime. So this is going to be our first transformation. And I'm just going to get rid of, not that far. Just going to get rid of some of these annotations to clear it up a bit. So the next thing we need to do is perform a transformation on A prime, B prime, C prime with a anti-clockwise 90-degree rotation about the point 1 minus 4. So let's just plot this point 1 minus 4. And the way we're going to perform this rotation is we want to create a new set of axes with this point as our origin. So let me just redraw this. So we can almost pretend like this is a new graph. And what we do is we're going to call this point here, we're going to call it our origin, which means we're going to pretend it has the point 0, 0. So we pretend this has the point 0, 0. So then A prime, B prime, and C prime have new coordinates now based on this new origin. So these would become, well, A prime, we can see from this point here is 5 in the x direction, and we can see it is 7 in the y direction, and I'll just get rid of these. So we can do the same with B prime and C prime, and we get that B prime is 5, 2, 5, and 5. C prime is... So now, to get the 90 degrees anti-clockwise rotation, what we need to look at for each point is its x and y transformations. So if we took the point C prime, we can see that it's gone 2 across in the x direction and 5 up in the y direction. So now, what we need to look at, we need to go 2 in the y and then minus 5 in the x. So if we think about it, if we're doing a 90 degrees anti-clockwise rotation, we're going to be going into this quadrant here. So we're going to be going +2, and then we're going to go 5 in the minus x direction. So minus 5 is here. So this is going to be our, and in fact, let me just get rid of those. So this point here is going to be our C double prime. And now let's look at our B double prime and A double prime. So for B double prime, we originally had an x coordinate of +5. So that's now going to be our y coordinate. So for that, we go up 5. And we have originally a y coordinate of 5. So we now have an x coordinate of -5. So what this gives us is our new B double prime coordinate, which has the same coordinates as the original point B. And then lastly, we have our A prime, which has the coordinates 5, 7. So given that it had an original x coordinate of 5, it now has a y coordinate of 5. And given it had an original y coordinate of 7, it now has a new x coordinate of -7. And then we could just join these together. And this is going to be our new translated shape. So going to the question, which says, which one point on ABC is invariant under the combined transformation? Invariant means unchanging. So we can see here that we have an original B coordinate of -4, 1. And once we've completed these transformations, our B double prime is also the coordinate -4, 1. So the point B is invariant. So moving on to question 25a, and we have the quadratic equation x² - 5x - 6 is less than 0. So what we're going to do here is we're going to find our points where x equals 0, and then we're going to determine so what we're going to do here is make this equal to 0 are less than 0. So we're going to solve this equation, and then we're going to try and determine where this quadratic is less than 0. So we can do quite a simple factorization here. So we can rewrite this as x squared plus x minus 6x minus 6 equals 0. And then we can factorize this as x plus 1, x minus 6. So this gives us solutions here of x minus 1 and x equals 6. So now let's test around the boundaries to see where the quadratic equation is less than 0. So if we take the value x equals minus 2 and we plug this into our quadratic, we can see here that we get a solution of 8. Well, we know that 8 is greater than 0, so minus 2 is outside of this region. Likewise, if we took the value 7 and we plug this into our quadratic, this again gives us 8, which is greater than 0. So we know that the quadratic must be less than 0 in between this boundary of minus 1 and 6. So we have x is greater than minus 1 or less than 6. So now for part B, to plot this on the number line. So what we do here is we do the open circles above minus 1 and 6 and draw a straight line connecting them. So open circles mean that we do not...
So moving on to question 26, and we have this circle here, and we have a triangle inside of here, which is as follows. So we have our points R, Q, and P, and the point P is at a tangent to the circle, and the angle between the tangent and this line here is 2x. We're told this angle here is y, and the length RQ and the length PQ are the same. So we have RQ equals PQ. And what we're trying to prove is that y is equal to 90 degrees minus x. So how do we go about doing this? Well, the first thing I want to note here so I'm going to redraw the triangle inside the circle, and I'm going to have this as my point Q, this is my point P, and this is my point R. So this angle is y. And then what we can see here is that because the lengths RQ and PQ are the same, we know that this must be an isosceles triangle. So what we need to do now is look at the angle here at P must also be y. And what this says is, if we have a line that connects 2 points on a circle, and then we take the angle between that and the tangent, i.e. this 2x we have here, then the angle inside here, this Q, is going to be the same. So what we can say here is that the angle Q is 2x, which I'm going to put in here. So now we have 3 angles inside this isosceles triangle, which we know must add up to 180 degrees. So we can simplify this. So we have 2y plus 2x equals 180 degrees. Therefore, 2y equals 180 degrees minus 2x. And we can divide both sides by 2, and we get that y is equal to 90 degrees minus x. So moving on to question 27, and we're asked to work out the square root of 2 and 13/16 minus 2 over root 5. And we're asked to write this in the form a root 5 over b, where a and b are integers. So I want to tackle this part first. And what I want to do is I want to rewrite this mixed number as a proper fraction. So we can think of a mixed number as it's an integer plus a fraction, but they're essentially added together. So we can think of this as 2 plus 13 over 16. So if we want to convert this to a proper fraction, then we need to make this 2 into a fraction, and we want it with the same denominator. So what we want to do is we want to write 2 as something over 16. Well, this is going to be 32 over 16. So now this part 1 becomes the square root of 32 over 16 plus 13 over 16, and therefore this becomes 45 over 16. So we have the square root of 45 over 16, and using our knowledge of surds, this is the same as root 45 over root 16. So we can simplify this, and we can rewrite root 45 as root 9 times root 5, and then root 16 is just 4, and then root 9 is 3. So substituting this in, I now have 3 root 5 over 4 minus 2 over root 5. So what I want to do now, I want to try and eliminate this surd from the bottom. So what I'm going to do here is I'm going to multiply this 2 over root 5 by root 5 over root 5. So root 5 over root 5 is just 1, so this doesn't change the actual value. And when I do this, I get 2 root 5, and then root 5 times root 5 is just 5. So I get 2 root 5 over 5. So now, let me substitute this in, and I get 3 root 5 over 4 minus 2 root 5 over 5. Well, now, let's find the common denominator. So what I'm going to do here is I'm going to go 3 root 5 over 4, and I'm going to try and get a common denominator of 20. So I need to times top and bottom by 5. And this is minus 2 root 5 over 5 times 4 over 4. So I'm going to get 15 root 5 over 20 minus 8 root 5 over 20. And this gives me 7 root 5 over 20, where 8 equals 7 and b equals 20.
So thanks for watching, guys. Hopefully you found that useful. If you have any questions or even just feedback for how this could be more helpful, leave a comment and I'll get back to you as soon as possible. If you haven't already, hit that like button and subscribe to our channel. As I said at the start, this really will help us grow, so your support is really appreciated. With that said, all the best, guys, and I'll see you at the next one.